Welcome to the XCS EI Console for OpenTravel product quick tour. The XCS EI Console for OpenTravel provides developers and business analysts with a best-of-breed solution for integrating systems. If you have a need to connect your systems with each other or with your business partners, you have a need for the XCS EI Console. The XCS EI Console provides a paint-by-numbers approach for defining the connectivity, transformation, and other data manipulations required to interface heterogeneous systems. Furthermore, the XCS EI Console for OpenTravel has been specially engineered to meet the unique needs of the travel industry, and, more specifically, of those leveraging the OpenTravel XML formats. Over the next several minutes, we'll provide you with a quick tour of how the XCS EI Console for OpenTravel can save you time, improve speed to market, and vastly reduce the effort required to integrate your systems. The first screen you see when opening the XCS EI Console for OpenTravel is the Route File Management window. This screen presents you with a list of all of the various OpenTravel templates. One exists for each and every one of the OpenTravel provided messages. Developing a new interface between systems is as simple as selecting the appropriate template, cloning it, and configuring it to meet your needs. Interface configuration in the XCS EI Console for OpenTravel is simple. The developer defines any required source and target systems, and then moves from left to right through a set of predefined stages, configuring the behavior of each one of those. Each interface begins with a source system providing data to a listener component. The listener defines the connectivity from the source system. Those listeners can be either passive or proactive, meaning the XCS EI Console may go out and look for data against a directory, FTP, or email, or sit and wait for information to come in through HTTP, web services, or message-oriented middleware. The developer need only select the appropriate listener type and then fill out the configuration tabs that are presented. After data is acquired from the listener, it's passed along to a set of processor components. This optional stage allows the developer to validate the data, decrypt the data, decompress it, deal with attachments, etc. After the processing stage, the information is pushed to a source transformation. The source transformation takes the data from the proprietary format of the source system and translates it into a common or canonical model to be used for this interface. First, if the data is not XML already, it will be translated into an XML format. For instance, our first source system will provide a Microsoft Excel spreadsheet, whereas our second will provide a tab-delimited file. A number of different transformation modules are available for turning different flavors of data into or out of XML. The XCS EI Console for OpenTravel provides the file specification editor. This is used for delimited or fixed width file processing. After data has been translated into an XML format, we use XSLT and the XCS EI Console's data mapping tool to create the logical mapping between source system fields and target format elements. The XCS Data Mapper provides simple drag and drop support for these mapping operations. The source and target format are simply loaded from the appropriate metadata file. And then relationships between source and target fields are simply dragged and dropped into a center panel. Under the covers, the mapping generated is W3C standard XSLT, meaning the underlying transformation is completely portable. The data mapper also includes an XPath editor, as well as a fully integrated XSLT debugger. When managing source or target formats, schemas can be extended using the mapper's full-featured schema maintenance functionality. Mapping notes can also be maintained inline. Inline documentation for the OpenTravel schema is also provided and is fully searchable. Returning to the main route grid, once data has been transformed into the canonical format, we move on to the routing module. The routing stage allows XPath-based rules to determine which one of potentially many target systems to send the data to. Alternatively, data can be sent to all defined targets. Also defined at this point are transaction monitors. Transaction monitors provide proactive notification of errors that happen at any point during the interface process. The target transformation is responsible for translating data from the common format, in this case the OpenTravel message, into the specific format accepted by the target system. If the target system can accept that canonical format, the data may just be relayed along. If further transformation is necessary, the same tools are available in the target transformation that we saw on the source transform side. Information is first mapped into the target format with the data mapper, and then translated as required into a different physical representation through the various transformation modules. Finally, the transport stage handles the connectivity to the downstream target system. Finally, the target system will receive the data either asynchronously or, in the case of a real-time system, it may provide a synchronous response back to the transport, which may in turn call another flow. After the connectivity and transformation has been defined in the EI console's main route screen, the developer or analyst will switch to testing mode. In testing mode, the developer may unit test or integration test various stages of their interface. The starting stage and ending stage for each test may be configured. Upon executing a test, the question mark that marked each stage will turn into either a check mark or an X. A check mark indicates success, and X indicates failure. The developer can then look at the inbound data, in this case, a binary Excel spreadsheet, its conversion into XML, its subsequent mapping onto the OpenTravel standard, and any further data transformation. Once the developer is happy with the results of the test, they'll return back to the file management screen, select their interface, and optionally deploy it to a separately licensed XCS EI platform server component. So there you have it. It really is a paint-by-numbers approach to building interfaces that leverage the OpenTravel standard. By learning to build interfaces in the XCS EI console, you can drastically reduce the cost of integration projects, increasing your speed to market and reducing your integration risks. Once you're ready to get started, just open up the tutorial that comes along with the XCS EI console for OpenTravel. It will walk you through the process of creating the interface we just toured today.